Bright Duty. Every student matters.
Express the ratios cos A, tan A, secant A in terms of sin A. Right. So first of all, I'll represent cos A in terms of sin A, which is very simple because we know that sin square A plus cos square A is equal to 1. Right. So I can say cos square A is equal to 1 minus sin square A. Hence cos A is equal to square root of 1 minus sin square A. Okay. So I have represented cos in terms of sin. Okay. Now what is tan A? Tan A is nothing but sin A by cos A. So I can write it as sin A by 1 minus sin square A. Okay, I've used this value of cos here. Okay, so this is value of tan A. And what is secant A? Secant is just the reciprocal of cos A. So I can write it as 1 minus sin square A. Okay, so these are the ratios cos A, tan A, secant A in terms of sin A. Right? Let's look at this question now. This question says prove that secant A into 1 minus sin A into secant A plus tan A is equal to 1. Okay. So what we can do here is, let's write the left hand side first, which is secant A 1 minus sin A secant A plus tan A. This secant A can be written as 1 by cos A. Okay. So if I multiply this secant A in this bracket, what will happen? It will give me secant A minus secant A into sin A. Okay. And the second bracket is secant A plus tan A. Right. Now secant is nothing but 1 by cos A and sin by cos A is nothing but tan A. So this can be written as secant A minus tan A. This expression is tan A, right? Because sin A by cos A is tan A. So secant A minus tan A into secant A plus tan A. Now we already know that it is equal to secant square A minus tan square A, which is nothing but 1, right? So it is equal to right hand side. Hence proved. Right? We have used the identity that secant square A minus tan square A is equal to 1. Right? Okay, let's look at this question here. This says prove that this is the left hand side and this is the right hand side. Let's take the left hand side and try to prove it equal to right hand side. What is left hand side? Cot A minus cos A divided by cot A plus cos A. Right? Now you can see that cot A is equal to cos A by sin A. Right? So I can put it as cos A by sin A minus cos A divided by cos A by sin A plus cos A. Now you can see that we can take cos A common in the numerator. So I will be left with 1 by sin A minus 1, and in the denominator if I take cos A as common, I will have 1 by sin A plus 1 inside the bracket. Cos A can be cancelled here. So this is 1 by sin A. 1 by sin A is nothing but cosecant A minus 1 cosecant A plus 1, which is equal to right hand side. Right? This question here says prove that, again a left hand side is given and we need to bring the right hand side from this. So left hand side given is sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1. Right? And we need to bring secant theta minus tan theta from it, right? So let's try to convert this expression in secant and tan. How can I do that? Let's divide it by cos in the numerator and denominator. So if I divide numerator and denominator by cos theta, what will happen is this will become sin theta by cos theta, that is tan theta. Cos theta by cos theta will become 1. 1 by cos theta will become secant theta, right? And denominator here will become sin theta by cos theta will become tan theta. Cos theta by cos theta will become 1 minus secant theta, right? Okay, so now what you can do is, I have already told you secant theta plus tan theta minus 1 divided by, I can write this expression as 1 minus secant theta minus tan theta, right? And in the introduction we did that secant theta minus tan theta is equal to 1 by secant theta plus tan theta. Why? By using this identity, secant square theta is equal to 1 plus tan square theta. We used this identity, so we can say that secant theta minus tan theta is equal to 1 by secant theta plus tan theta, right? So here I can replace it by 1 by secant theta plus tan theta. So let's write it, secant theta plus tan theta minus 1 divided by 1 minus 1 by secant theta plus tan theta, right? Why I am doing it is that I need to cancel these terms. Now if you see secant theta plus tan theta minus 1 divided by, if I take the LCM here, it will be secant theta plus tan theta minus 1 divided by secant theta plus tan theta, right? Now I can cancel these, and this secant theta plus tan theta will come in the numerator, and which is equal to 1 by secant theta minus tan theta, by using the same identity, secant square theta minus tan square theta equal to 1, which is the right hand side, hence proved. Here I can tell you one more manipulation. You could have solved this question by the second way. How? You could have replaced this secant theta plus tan theta here by 1 by secant theta minus tan theta. Let's do it here and you will understand. If in the numerator I write secant theta plus tan theta as 1 by secant theta minus tan theta, right, and this minus 1 as it is, divided by tan theta minus 1, tan theta plus 1 minus secant theta, right? If I write this expression as this, what will happen is, it will give me, if I take the LCM as secant theta minus tan theta, the numerator will become 1 minus secant theta plus tan theta divided by secant theta minus tan theta, and this divided by tan theta plus 1 minus secant theta, right? So now you see this and this gets cancelled, okay? So I will be left with 1 by secant theta minus tan theta. But before using these manipulations, you have to explain it to the teacher that the identity is this, secant square theta equal to 1 plus tan square theta, and I will bring tan square theta on the left hand side, secant square theta minus tan square theta equal to 1, and then a square minus b square can be written as a minus b into a plus b, hence this manipulation can be used, okay? So you better explain it for the convenience of the teacher.